All right, welcome to the lesson on angle types and the linear pair postulate. What we're going to start with here is our adjacent angles. Now, coplanar means they exist on the same plane. Share a side, here we have a side here and a side here, but this is a side that they share a vertex in this case. The vertex is point Y. And then no interior points are shared, meaning nothing in here is in here. So we see that every point that exists in A does not exist in B, and every point that exists in B does not exist in A. The question I have is, can you have three distinct adjacent angles? And in class we talked about this, and the answer was no, because technically you could, I suppose, have another one coming out this way if you can view that in the third dimension, but they wouldn't be coplanar, so we couldn't have three distinct adjacent angles. Our next type is vertical angles. So we have A and B being vertical angles here, and angle D and angle C being vertical angles there. It's two angles and their sides are opposite rays. What we're saying here is right there at the point of intersection, the single point where these two lines cross is going to be the vertex for each of the angles. C, D, A, B, each of their angles, vertices, is the same. It's this point right there, right in the middle. But the interesting thing is, here's a straight line making opposite rays going on infinitely. Suppose I should have little arrows at the end of each of these, and these two lines are also opposite rays. Yes, angle A and angle C are adjacent, and angle D and angle B are adjacent, but they are not vertical. Vertical means they share that vertex and are opposite rays from each other, can construct opposite rays. Our next is going to be our complementary angles. Complementary angles are always going to be two angles who have a sum of 90 degrees. Each angle is the other's complement. So in this particular case, angle 1 and angle 2 are still complementary, even though they're not connected. In this particular case, angle A and angle B are connected. They are adjacent angles, and they are complementary angles as well. They share this side right here. These two do not share a side or a vertex, but both of them have a sum of 90 degrees of their interior angles. Now the question was, is there a complement for a 100-degree angle? Not unless you can make a negative angle, and you can't do that. Our next is very similar. Instead of complementary, we have supplementary angles, and instead of 90 degrees, we have 180 degrees, which is halfway to our circle. 130 plus 50 is, of course, 180. 110 plus 70 is, of course, 180. We're sharing the vertex here. We're adjacent angles here. We're not in these two, but they still have a sum of 180 degrees. Each angle is called the other's supplement, and then a question we asked in class, is there a supplement for a reflex angle? And the answer would again be no. You'd need to talk about negative angles, and you can't do that. Our next is our linear pair, and this will lead us to our linear pair postulate. Adjacent angles, distinct sides are opposite rays, and they form a straight angle. So here's the opposite ray that makes this adjacent, meaning it shares a vertex, shares a side. So in the sense that this is our straight line, our opposite ray, the linear pair. Just again, think about that word linear. It just makes a line. So angle 1 and angle 2 together make the line, and that's line AC, BC, AB. Any way you want to name that line, it's still the line going on infinitely, this direction and this direction. Now the question here, I thought this was a good question. This is the same little GIF from our previous slide. Is this a linear pair? And of course the answer is no. They're not adjacent, meaning they do not share a side in the vertex. They do make a complementary angle, but they are not adjacent. Now the linear pair postulate, that's what we're going to be working on today. And if two angles form a linear pair, then they are supplementary, meaning if two angles form a linear pair, my baby's crying, hold on. All right, put her to sleep. If two angles form a linear pair, then that's obviously a straight line. So what we're saying is the measure of CAD plus the measure of DAB. Remember, always name your angle with the vertex in the middle of the letters. A is the vertex of both of those angles. They both share the vertex of A. And so what we're saying here is that this and this added up equal 180. Make a straight angle, make an angle that is just a straight line. So whatever this is plus whatever this is always has to equal 180. This is where we introduce the algebra to it. We say 4x plus 36 is this. We say 2x plus 24 is this. So what we want to find out is, are these angles together 180? Well, we know they're 180. The question is, how do we put that together as an algebra problem? We say, hey, I know I have this, I know I have this, and together they equal 180. Well, what's the mathematics meaning together? It's adding, it's the sum, and so what I'm going to do is send that back. There we are. Here's our question. 4x plus 36, that's this. 4x plus 36 together with 2x plus 24, that's this, equal 180. Now, how do we solve that? Let's go on to the next slide and determine it. Alright, so here we are on our next slide, and we're looking at 4x plus 36 plus 2x plus 24. All we want to think about is just combining our like terms. In this case, it's 4x and 2x, which gives us 6x, and 36 plus 24, 30 plus 20 is 50, 6 plus 4 is 10, so that's 6x plus 60 equals 180. Then we're going to go back and say, hey, minus 60 to each side, 6x equals 120. Then we're going to say divide each side by 6, x equals 20. So the measurement is 20 degrees is x. That's what x equals. So the measurement of the first side is 4 times 20, which is 80. 80 plus 36, which is 80, 90, 100, 116 degrees. 2 times 20 is 40. 40 plus 24 is 64. And if we see, sure enough, 116 plus 64 do in fact equal 180 degrees. Alright, and now the last thing we're looking at today is our angle bisector. So an angle bisector is just a ray, and here's our ray that divides a segment into two congruent, that's the equal sign with the tilde on top, two congruent angles. Congruency meaning they're exactly the same, and it has its endpoint at the vertex. So very much like our segment bisector, this is just our angle bisector. It just cuts it right in half, saying that everything in here is exactly the same amount as everything in here, that this point is the same distance as this point from that line. So this is going to be important when we're talking about constructions with triangles, understanding that we can cut any angle right in half if we have its measurement. Now let's have a little practice with that one. Let's just take a look at a couple different ways to approach angle bisectors. We can either say ray BD is the angle bisector of angle ABC, or we can say angle ABD is congruent to angle DBC. In this particular drawing, that would mean that they are bisectors. Now, it is a bisector rather, given the number, let's just say 31 degrees. If I'm given that, I know because they're congruent, I know that this angle has to be congruent to that angle. If this is the angle bisector, which in this case it is, that obviously has to be 31. Or if I'm given an entire angle measurement to this angle, let's say angle ABD is 62 degrees, which is going to be the same number, 62 degrees, I just say what is 62 divided by 2, and I'm going to get my 31 there and 31 there. So that's our lesson on angle bisectors, the linear pair postulate, and angle types. Good luck studying, have fun.